Welcome back. In this video, we're going to be talking about linear equations in two variables, which are equations of straight lines. Just a reminder that when we say linear equations, we're talking about equations where the degree is 1. And since it's a linear equation in two variables, then that means each variable has highest power of 1. And so here I have that any linear equation could be written in this form, could be written as y equals mx plus b. The highest power on the y is 1, and the highest power on the x's are also 1. That's what makes this a linear equation. If there were any y squareds or x squareds or other higher powers, then it would not be linear. And so we know for linear equations, for equations of straight lines, the way that we can describe a straight line is by its slope. Does the line tend to go up and to the right? Does the line tend to go down and to the right? Is it a horizontal line? These are all questions that can be answered by describing that line by the slope. Now, we only have slope defined for non-vertical lines. For vertical lines, the slopes are undefined. So for a vertical line, if somebody were to ask what is the slope, the answer is undefined. But for any other line, horizontal or slanted, we find the slope by looking at the change in the y values divided by the change in the x values. The symbol that I have here, that little triangle, when I have that in front of the y, that's actually the Greek letter delta. And we would read that as the change in y. How much does the y value change? And similarly, the denominator, delta x, that's the change in x. How much do the x values change? And so to find this, we just take the y coordinates for the 2 points and find their difference. How far apart are they in the y direction? And also how far apart are they in the x direction, the difference between the x values. One thing to notice here is that I'm keeping my order of the 2 points constant. I'm going from my second point to my first, y2 minus y1, and then in the denominator from the second point to the first again, x2 minus x1. And that's to keep things consistent. I don't want to switch the order up with one x value going from the first point to the second and the y value going from the second to the first. I have to be consistent. If I'm calculating my differences, my changes in y's and x's, starting from one point going to the other, starting from the same point going to the same other point, and that will be how I'll calculate my slope. If we're thinking about a vertical line again, the slope is undefined, and the reason why this slope is undefined, if you're thinking about any vertical line, any 2 points that you happen to pick on that vertical line would have the same x values. So if you were to calculate the difference in the x values, the difference in the x values for a vertical line would be 0. In other words, the slope would have a denominator of 0. That's why the slope is undefined for vertical lines. Now for slopes, how we interpret them visually, they're a measurement of how much we're going up or down as we move to the right. A way that we describe it in words, we sometimes will call the change in the y values the rise, how much you're going up and down, and the change in x, we call that the run, how much we're going from left to right. So if we're measuring the slope and we find a slope of a line as being negative 3/5, this is telling us that for every 5 units that I go to the right, that the negative part is telling me that I would then be going down 3 units. This would be a line that's trending downwards. This is a line that's a decreasing line. On the other hand, if you had a slope of 5/6 positive, that would mean that for every 6 units you go to the right, you would be going 5 units up. This would be trending up and to the right. That would be an increasing line. And of course, if you had a slope of 0, that would be a horizontal line, because if you're thinking about something that is a value of 0, 0 is the same thing as 0 over 1. So you could think of that slope meaning that for every 1 unit to the right, you don't go up or down, which means you're just going to the right. In other words, it's a horizontal line. So positive slopes, those are increasing, we go up and to the right. Negative slopes, those are decreasing, we go down and to the right. Slopes of 0, those are horizontal, we're just going to the right. So we want to find the slope of the line passing through these 2 points, and easy enough for us to calculate. Our slope is the change in the y values over the change in the x values, delta y divided by delta x. And we're going to go from our second point to our first when we do our subtractions. The y value from the second point minus the y value from the first point over the x value from the second point minus the x value from the first point. And then we just need to simplify that. Numerator is -6 and denominator is +4. And just like any other fraction, we'll want to express that in simplest terms. So I will say, instead of -6/4, I'll say -3/2. Just as a little side note here, if we wanted to talk just for a brief moment about our calculator, I keep going back to our calculator's fraction function, but it's a good skill to have, is to be able to use your own technology tools to help you. If you were to enter in, for example, -6/4 into your calculator, how I would enter that would be -6 fraction 4. And the nice thing about our calculator is, in addition to doing arithmetic with fractions, it also simplifies fractions for you. So if I entered in -6/4 and then hit equals, my calculator will give me as the output -3/2. And that's how I would know, without needing to do any of the heavy lifting myself, that my slope simplifies to give me -3/2. And that's for any fraction that you're working with. If you enter it in and hit equals, the calculator always gives you that fraction in simplest terms. One more reason to love the calculator we have. All right, so we have our slope. And if we're thinking about the slope that we've got, -3/2, if I were just interpreting that, that means that for the line that passes through those points, for every 2 units it goes across to the right, it goes 3 units down. In other words, this is a decreasing line. Our line slopes down and to the right. And of course, you can visually confirm that. If you were to plot these 2 points on the x and y plane, you can see that if you connected the two, that if you move from the left point to the right one, you are going down. You're heading down and to the right. Now, for linear equations, equations of straight lines, there are 3 forms that we have, and they all have their uses. The one that we usually use to give our final answer in is called general form. So this is x's and y's on one side, constants on the other. And if you can have all the coefficients being integers, then yes, please do. And that's the form that we usually give our final answers in. But unfortunately, that's not really a useful form for things like graphing, because here the coefficients, the a, the b, the c, they don't really tell us anything immediately obvious about what the line looks like. The other forms that we have are more useful for constructing the equation itself. The second one, the slope point form, this is not usually how we leave our answer. This is the form that I use when I'm creating the equation of a straight line. This equation only requires me to know the slope of a line and one of the points that that line passes through, and using slope point form, I can now create the equation of the line with that slope passing through that point. Again, this isn't really for graphing purposes. Usually the slope point form is what I start with, and then I end with by rewriting it in general form. Now, the one that we usually use for graphing is the slope-intercept form, and that's because this has something where the coefficients, the constant term and the coefficient of x, actually tell us something about how the graph looks. So in this form, y equals mx plus b, we have that m is the slope of our line, and the point 0b, that's the y-intercept for our line. So if you have the equation in slope-intercept form, it's actually really easy to graph, because already you know one point that's on the line, and then you can use your slope to figure out other points that are on the line. And that's usually the form that I'll be using when I'm graphing equations of straight lines. So in this example, we want to find the equation of the line that passes through those 2 points and then give our equation in general form. So no graphing with this one, we're just going to write an equation. And we know that the first thing that I'll need to do is, if I want the equation of a line, I'm probably going to be using slope point form. I've got lots of points, I don't have a slope, so that means my first move is for me to calculate what my slope is. So my change in the y values divided by the change in the x values. There we'll be going from the second point to the first. Y value minus the y value from the second point minus the first point. X value from the second point minus the x value from the first point. And that gives me positive 3/5. And now, using my equation of the line, the slope point form, I'm going to use the slope of 3/5, and I'm going to use the point -2, 1. It doesn't really matter which of the 2 points you're using, and this is a fun little exercise for you to do later on, is to redo this question, except instead of using the point -2, 1, using the point 3, 4, and you should get the exact same equation of our straight line. So the slope point form is y minus the y coordinate equals slope times x minus the x coordinate. And now we'll put in what we have. Y minus the y coordinate equals slope times x minus the x coordinate. And then the only thing that's left for us to do is simplify. So this is y minus 1 equals x minus -2 is the same thing as x plus 2. So we'll have 3/5 x plus 6/5. And we want our equation in general form, so that means I want x's and y's on one side, I want constants on the other, and if I can, I'd like to have only integer coefficients. I don't really want fractions, so I'm going to multiply everybody by 5. If I multiply everybody by 5, on the left side I'll have 5y minus 5. And on the right side, multiplying everybody by 5 will get rid of all of those denominators of fractions. I'll have just 3x and plus 6. And so it's going to be easy enough now for me to rewrite this in standard form, or general form rather, by bringing the x term to the other side. And bringing the constant term to the other side. And so now I have my equation of my line, -3x plus 5y equals 11. If you don't like it starting with a negative, you could multiply everybody by -1. So you could also rewrite this as positive 3x minus 5y equals -11. I know some books try to avoid having the first thing on a line being a negative. So some books, if you've been using those kind in the past, you might be wanting to make that -3x into a positive, and so that's fine. You could multiply everybody by -1 to make that happen. Either would be acceptable. Now, the one thing that I wanted to mention before we finish this example and move on to the next is that since this line is supposed to contain those 2 points, -2, 1 and positive and 3, 4, then both of these points should satisfy our equation. In other words, if you were to put 3 in for x and 4 in for y, it should make left side equal to the right side. And if you were to put in -2 in for x and 1 in for y, it should also make the left side equal to the right side. So that's one more thing that you can do if you have a few minutes. You can pause and confirm that yes, indeed, these 2 points are on the equation of that line that we just found, and you know that because those 2 points satisfy that equation. Okay, so we have another example here. This one we will be graphing. We've got an equation for a line given to us, and we want to start off by finding the slope and the y-intercept. That's what we'll need to find. And then once we know the slope and the y-intercept, we can find 2 other points on our line, and then eventually we'll get to the graphing side of things. Now, if you want slopes and y-intercepts, then I guess you're using slope-intercept form. So that means we're going to take our equation and rewrite it where we just have y by itself on one side. So I'm moving the x to the other side. I'll divide both sides of the equation by -2. So I have the equation of my line being y equals 3/2 x minus 3. So that tells me that my slope is 3/2, and my y-intercept is the point 0, -3. Now, as far as finding 2 other points on the line, this comes back to us thinking about what our slope means. A slope of 3/2 means that we're going to be going to the right by 2 and then going up by 3. And if we're thinking about what that means as far as x's and y's, left and right, those are the x values. If you're going right by 2, then you're taking whatever the x value is from the point that you're starting at, and you're adding 2 to it. Vertically, those are y values. If you're going up by 3, you are taking the y value that you had and increasing it by 3. So to go from one point to the next using our slope, we'll increase our x values by 2. That'll make us go 2 to the right. We'll increase our y values by 3. That'll make us go 3 up. In other words, that'll make us travel with a slope of 3/2. So for a second point that we have, one of our points is 0, -3. Another point we can find by taking that y-intercept and adding 2 to the x value and adding 3 to the y value. In other words, we'll have now the point 2, 0. And if we want to find another point, we can take 2, 0 and do the same thing. Go 2 to the right and then up by 3 to give us the point 4, 3. So now we've got 3 good points. We have the y-intercept, we have 2, 0, so that's actually an x-intercept, and we have a third point, 4, 3. Now, again, just to recap, what I want is a well-labeled graph of this equation, which means I need my x and y axis labeled as x and y. I need tick marks, and I need those to be labeled with numbers. I also need any points that I plot to be labeled with their coordinates. The exceptions will be the x-intercept and the y-intercept because those are crossing the axis at one of our tick marks. So I won't need to label those, but I definitely will need to label that point 4, 3, and I'll also need to label my graph with the equation that I'm graphing. Now, when you're labeling it, you can choose to label it with the way that you originally had the line, or you can label it with the slope-intercept version, but I do expect to see one of these two next to the line once I've graphed it. So let's get into that and start graphing. So our points that we had 0, -3, we had 2, 0, and we have 4, 3. And now I'm going to draw my line. go. And I'm just going to do a little bit of fixing up here. So here, there's my point. I'll make it look a little bit more visible. That I'll need to now label for 3. This point was -3, 0, and this point is 0, -3, and that point is 2, 0. I should, for my lines, since lines continue forever in both directions, I should really draw arrowheads at the ends of my lines, because the line's not just stopping there, it's going off in both directions. So I'll draw little arrowheads on. And last thing that I need to have is the equation of my line labeled next to the line itself. So I'll label this as 3x minus 2y equals 6. This would be an example of a well-labeled graph of my line. If you're looking at this, you know what I've graphed because I've given you the equation of the line. You know where all the points are because I have enough information on the graph to tell you where the points are. I've got the coordinates labeled, I've got the tick marks labeled. I've also labeled which axis is the x-axis and which one is the y-axis. We can't always take it for granted that x is the horizontal and y is the vertical. You might, for some unknown reason, feel like having y be the horizontal and x being the vertical. And if you didn't tell me that, how would I know? So to be clear, we're always going to be labeling our axes, so we know which axis is which. So there we go. Although slope-intercept form is usually the easier form to work with when graphing straight lines, another way that we could graph straight lines, if we had an equation that was in general form, would be to use that to find x-intercepts and y-intercepts, which we can do actually fairly quickly. So even though general form doesn't really tell us much about what the line looks like, at least not directly, the 3, the 5, and the 20 here are not slopes or intercepts, I can actually fairly quickly find y-intercepts and x-intercepts. So for y-intercepts, a y-intercept happens when x is 0, and if we were to let x be 0, that means that the x term would go away. There would be no 3x anymore, there would be just 5y on the left side and 20 on the right. And so we could solve and find that y is 20 divided by 5, or 4. So we would have a y-intercept of 0, 4. For the x-intercepts, we have, again, those happen when y is 0, so we would let the y value be 0. That would get rid of the y term. We would have just 3x left on the left side and 20 on the right side. And when we solve for x, we would have x being 20 thirds. So we have the x-intercept 20 over 3, 0. Now, we're going to get to the graphing in just a minute, but before we do, I know that somebody out there is probably wondering, would it be fine for me to turn this into a decimal, like 6.666? Which I would say, let's not do that, because unfortunately, that would involve us rounding things off, and that means that we're no longer giving exact answers. We want to, in this course, not give approximate answers unless we've been told to start rounding things off, which means that for this, 20 thirds, that is the exact way of describing the number. I wouldn't turn it into 6.6. I wouldn't round things off. I do expect to see it left as a fraction. Now, if you want to run it through your calculator to get an idea of how big 20 thirds is, so that it's somewhere between 6 and 7, that's fine. But when I label things, I'll be labeling that x-intercept with 20 thirds, 0. So I only have 2 points to label here. I'm going to be doing a well-labeled graph again, so that means, as per usual, I am going to be labeling the x and y axis. I'm going to be labeling tick marks. I'm going to label my points, the coordinates. I won't have to label 0, 4 because that is going to be at one of my tick marks. 20 thirds, 0 will not, so I will need to label that one, and I'll also need to label my line with its equation. I'll need to label that with 3x plus 5y equals 20. So let's do that. I have my y-intercept was at 0, 4, and my x-intercept was at about 6.6. 0.666-ish 23rds. And now I'm going to draw my line. And put arrowheads on my line. There we go. Now, the points that I need to label, the point 0,4, I don't need to label it with its coordinates because that point is at one of the tick marks. However, the other intercept, 23rds, comma 0, that's not at one of the tick marks, which means that is going to be something that I'm going to need to label. So 23rds, comma 0, I've labeled that point. And now the equation of my line, anywhere near the line is fine to label it. I'll put the equation down here, 3x plus 5y equals 20. And so I've got my axes labeled, the tick marks labeled, the points have been labeled, I've labeled the equation, everything is as labeled as it can be, so this is a nice, well-labeled graph of my line. For horizontal and vertical lines, those are actually fairly easy to give equations of. For a horizontal line, if we're thinking about how could we describe any sort of a horizontal line, you could describe it in terms of the y values. Any point that you pick along this horizontal line will have the same y value as any other point along that horizontal line. So the idea here is that if you know one point on a horizontal line, the equation is y equals whatever that y value is. So in other words, if the y-intercept of that horizontal line is 0b, then the equation of that horizontal line should just be y equals whatever that y-intercept is, y equals b. And similar sort of thing happens for vertical lines. For a vertical line, instead of all the y values being the same, on a vertical line, all the x values are the same. So if you had a vertical line that had an x-intercept a0, you could say the equation of that line is x value is a, that any x coordinate that we have on that line is going to be a. So here we've got a point, the point 3,4. We want the equation of the vertical line and the horizontal line that pass through that point. And if we're thinking about the vertical line, that equation is just x equals whatever the x coordinate is. So in that case, 3. And for the horizontal line, that's y equals the y coordinate, which is 4. There we go. So those are our equations of our horizontal and our vertical lines. Also, the reverse is true. If we have an equation given to us as x equals some number, we know that that's the equation of a vertical line. And if we're given something in the form y equals some number, then we know that that's the equation of a horizontal line. Now, we have two lines, suppose that we've got two lines that are not vertical, so they do have slopes. That's why I have to say non-vertical lines, because remember, vertical lines have undefined slopes. So you've got two non-vertical lines, and the slopes of those lines are m1 and m2. If the lines are parallel, then those slopes have to be equal, and vice versa. If those slopes are equal, then those lines are parallel. For perpendicular lines, those are lines that meet at a nice 90-degree angle. For perpendicular lines, the two slopes multiply together to give you -1, or the way that it's sometimes also phrased is that one slope is the negative and reciprocal of the other slope. That's sometimes how it's explained in classes. So you could think of it as multiply the two slopes together, and if it gives you -1, they're perpendicular, or take one slope, flip it, and change its sign, and there you have a slope of a perpendicular line. So here we have a point, 3,1, and we want this line to be perpendicular to 4x minus 3y equals 5. We want it to be perpendicular to this line, so the first thing we need to know, what is the slope of this line? So what is the slope of 4x minus 3y equals 5? And we find that by putting it into slope-intercept form, by bringing the x to the other side, dividing everybody by -3, and so you can say that your slope for this line is 4/3. Now, we're looking for a perpendicular slope, and for a perpendicular slope, that would be a slope that is the negative and reciprocal of that. So perpendicular slope to 4/3 that would be -3/4. So we know that the line that we're looking for, the line that passes through this point, since it's perpendicular to the other line, it has to have a slope of -3/4. So now the only thing left for me to do is to take that perpendicular slope of -3/4 and take that point 3,1 and create the equation of my line. So I will say, using our slope of -3/4 and our point 3,1, y minus the y coordinate equals slope times x minus the x coordinate. I'm using slope point form because that's what I have. I have a slope and a point. I put in the y coordinate, I put in the slope, I put in the x coordinate, and then now I just need to simplify. Now it was asking for general form, so that means same thing as before. I'm going to need to bring x's to one side, y's to the other, and if I can clear out all the fractions, I should. So actually that's what I'll do at this stage. I'll clear out all the fractions by multiplying everybody by 4. So that on the right side, 3/4 x, when you multiply it by 4, leaves us just with the -3, and 9/4, when I multiply it by 4, just leaves me with 9. And so now I can bring the x's and y's all onto one side and bring my constants to the other. And so now I've got my equation of my line, 3x plus 4y equals 13. So this line that I've created should be perpendicular to the line that I had on the previous page, the 4x minus 3y equals 5. As a fun little exercise, you can try to graph both lines and see from your graphing, does it appear that both of these lines meet at a 90-degree angle? They should, based on the math work that we've done, and that's a nice little graphing exercise for you to carry out. One more, which is us finding the equation of the line that passes through the y-axis at this point when y is equal to 3, or in other words, we're passing through the point 0, 3, or in other words, the y-intercept is 3. So if we're thinking about using slope-intercept form, we already know that our line is going to have the y-intercept of 0, 3, so our equation would be y equals mx plus 3. The only thing that we don't know about our line is what is the slope of our line. Now here's the other fact, is that the line that we're looking for has to be parallel to this one. So what is the slope of that line? And we'll find it the same way that I did before, by rewriting it in slope-intercept form, bringing the x's and constants to one side. I'll divide everybody by 2. And so my slope is -2. And I know that our line is supposed to be parallel to this, which means it has to have exactly the same slope. The parallel slope is also -2. And so now we've got everything we need. We know for our line that we're looking for, the slope is -2. and the y-intercept is at 0, 3. So the value for b here is 3. So I know that using my slope-intercept form, the equation of my line should be y equals negative 2x plus 3. Now, of course, I want this to be given in general form, so that means I'll need x's and y's on one side and constants on the other. So this is the final answer that I'll give to this question. 2x plus y equals 3. That would be a line that's parallel to the first line, and it also passes through the y-axis when y is equal to 3. And again, a nice little exercise for you to carry out would be to graph both of the lines and see that they both appear to be parallel. So this is the end of this section, and this is the end of this video. When we come back, we're going to see in 2.3 some applications of equations, some word problems.